Welcome back Year 7 to the second revision challenge video. Today we will be revising the particles topic that we studied right back in September. So let's start with the very first challenge of paper folding. Today you will need 8 boxes, so you can have 4 on each side or 8 on one side, it's up to you. Pause the video now until your paper is ready as you like it. There are 3 states of matter that we have learned about: solids, liquids and gases. In general, solids do not flow or change their shape. Solids stay in one place unless they're pushed or pulled. The volume of an object is the amount of space that it takes up. The volume of a solid does not change a great deal, and so even when squeezed, solids cannot easily be compressed or squashed into a smaller volume. Liquids can change their shape and flow. Liquids take the shape of their container. However, liquids do not change their volumes and they cannot be easily compressed. Gases can change their shape and their volume. They can spread out in all directions and they can also be easily compressed into smaller volumes. In box number 1, give 2 examples of each state of matter. Pause the video until you have written your answer. Scientists have developed a theory to explain the different properties of solids, liquids and gases. This theory has been refined and improved over many years of investigation using scientific methods. It is called the particle theory or particle model of matter. The particle theory states that all matter is made up of tiny particles. The particles are moving all of the time. There are forces of attraction holding the particles together, and the forces vary in strength in the different states of matter. In solids, the particles are held closely together by strong forces of attraction. The particles cannot move over each other but vibrate back and forth. The particles in a liquid are held closely together by fairly strong forces of attraction. However, the particles in liquids can move past each other. The particles in a gas are far apart from each other. The force of attraction between the particles are weak, so gas particles are free to move about in all directions. In your second box, write down why you can compress or squash a gas, but not a solid or a liquid. Pause the video until you have your answer written down. When energy is transferred to or from a substance, it will change state. When a solid is heated, it absorbs energy and it melts, turning into a liquid. If the liquid is heated, it absorbs more energy and it boils, turning into a gas. These changes absorb energy from the surroundings. Evaporating is when a liquid turns into a gas slowly, at temperatures that are below its boiling point. Puddles dry up because they evaporate, they don't boil. If a gas is cooled, it transfers energy to the surroundings and turns into a liquid. This is called condensing. If a liquid is cooled, it transfers energy to the surroundings and turns into a solid. This is called freezing or solidifying. In box number 3, make a list of 6 things that you can melt. Pause the video until you have your answer written down. Scientific theories are always changing. Through new experiments and observations, scientists can improve their ideas and explanations. Sometimes scientists even use the results of experiments from the past to further develop their ideas. In 1827, the Scottish scientist Robert Brown was using a microscope to study pollen grains in water. He observed that the pollen grains moved about randomly in different directions. He discussed his observations with other scientists, but they couldn't explain why it was happening. This movement later became known as Brownian motion. If we were to watch one individual pollen grain, we would see it moving jerkily in different directions. Later, scientists, including Albert Einstein, used the particle theory to explain Brownian motion. The particle theory says that water consists of tiny particles moving about. Water particles therefore bump into the pollen grain and push the pollen in that direction. In box number 4, give another example of where we can see Brownian motion happening. You may need to Google this for more help. Pause the video until you have your answer written down. When particles of one substance spread out and mix with particles of another, we call this diffusion. You can smell a substance when some of the particles from that smelly substance are inside your nose. This can only happen if the particles of the smelly stuff are moving and spreading about in all directions. Diffusion is an important process inside our bodies. Diffusion allows particles of essential substances to pass into the bloodstream and to be carried around the body. Diffusion also happens in plants to keep them alive. Waste products are also removed by diffusion. In box number 5, name one organ of the human body and one organ in the plant where diffusion takes place. Pause the video until your answer is written down. We are surrounded by air and its particles are hitting us all of the time. This causes air pressure, which is the force of these particles hitting a surface. We don't normally feel this pressure, but we can sometimes see its effects. Examples include higher air pressure inside car tyres, pushing out and keep the tyre inflated. Sucking up liquids through a straw works because of air pressure. When you suck, you reduce the air pressure inside the straw, and the air pressure outside of the straw pushes on the liquid, and this is greater than the pressure inside the straw, so the liquid is pushed up the straw. A vacuum is a space that does not contain anything, not even air. We created a vacuum by heating a small amount of water inside a drinks can, which expanded and pushed the air out of the can. When we flipped the can into some cold water, there was no air to push from the inside of the can, and the air pressure on the outside crushed the can. So in box number 6, explain why a tyre gets bigger when you pump them up. Pause the video until your answer is written down. Just like gases, liquids exert pressure on objects due to collisions between the liquid particles and the object. The amount of pressure exerted depends on both the density of the liquid and the depth of the liquid. The deeper you go, the greater the weight of the liquid above the object, and the greater the liquid pressure. So in box number 7, draw a side view of a lake and label where the pressure will be greatest. Pause the video till you have your answer written down. Density is a word we use to describe how much space an object or substance takes up, its volume, in relation to the amount of matter in that object or substance, its mass. Another way to put it is that density is the amount of mass per unit of volume. If an object is heavy and compact, it has a high density. In box number 8, write down the equation we used to calculate the density of an object. Pause the video until you have got your answer written down. Okay, now that you have finished, have a look at the answers. I will check question 1 and question 3, but you can mark 2, 4, 5, 6, 7 and 8. If you get 6 or more, or you've got 6 and you need me to check and see if you've got more, bring me your sheet. If you have 6 or more, you can have a house point for knowledge for success. Fantastic revision today. If you didn't get 6, have a little look at where you went wrong and come and see me anyway for some more work. Well done.